Okay, at the end of the last video we were finishing up on 22b and we were writing the equation of the line where in part A we had found the slope to be 1/2 and we were working with this point that we were given right here. So here's x1 and y1, and so I'm just going to plug them in. So y minus y1 equals my slope times x minus x1. And again, on a multiple choice you may be asked to solve for y, but in a free response situation you could leave your equation just like that. You don't need to solve for y. Okay, also in that question it asks you to use that to approximate f at 1.2. I'm not so worried about you being able to do that because that's really next semester and we can omit C and D. So moving on to number 23. On number 23, it tells me that a graph of a function exists of a semicircle and two line segments that are shown, and we want to be working with an integral. So remember that the integral is the area that you have accumulated underneath or between your graph and your x-axis. Okay, so this is kind of what we're looking at here is this integral. And that's what g is. So I want to find g at 3. So what they're asking me to do there is to fill in a 3 for that x value right there. So I want to find the area that I have accumulated between 0 and 3 of my function that I am given. Okay, so the first part of my function that goes from 0 to 2 is a semicircle, or part of a semicircle I should say, that has a radius of 2. So I'm going to start with the area of the first part here. I'm going to call this area number 1. Okay, so area number 1 is going to be a fourth of a circle. So I'm going to take a fourth of the area of a circle, which is pi r squared. So that'll give me 1/4 of pi times my radius, which is 2 squared. And so 2 squared gives me 4, and 1/4 of 4 gives me pi. That's area number 1. Okay, so 1 pi right there. All right, then I have a triangle that goes over here to 3, and that point right there is at -1. So here's my right triangle that I'm working with here. So this is going to be area number 2 right here. So area number 2, I'm working with a right triangle, so I want to work with 1/2 of my base times my height. So that's going to give me 1/2 of my base, which is 1, times my height, which is also 1, and so that gives me 1/2. But remember that that drops below the x-axis, so that's actually going to be a negative amount of area right there. Okay, so to find all of it from 0 to 3, I'm going to add together my 1/2 and my pi. This is -1/2, so I'm going to say that my area is pi minus 1/2. Okay, in part B, it wants me to find all of the areas on the open interval from -2 to 5, which is my whole graph here, at which g has a relative maximum. Okay, so this is the graph of f, and so since g is the integral of f, g prime is going to be equal to f at t. Okay, so the graph that we are given is the graph of the first derivative. Okay, so I know that this thing is going to have critical points or maxima and minima when I have zeros on my graph. Okay, so my zeros on my graph are occurring at 2 and at 4. So let's look at that just on a number line, 2 and 4. I have another one at -2, but I don't know what's happening on the other side of -2, so I don't want to talk about that one. Okay, so on this side of 2, I notice that my graph is positive, and on this side of 2, between 2 and 4 here, I notice that my graph is negative, and then above 4, my graph is positive again. So I'm going to have a graph that is increasing, and then decreasing, and then increasing. So just to get a little sketch of what this looks like, it might look something like this. So increasing, and then decreasing, and then increasing, and so there is my maximum point. So we're going to have a maximum at x equals 2. Okay, if it had asked me for a minimum, this would be a minimum point right here where x is equal to 4. Okay, and where it asked me to justify my reasoning, I would say because g prime changes from positive to negative. Okay, so don't talk about the graph of G, talk about the graph of G prime. Okay, on part C, they asked me to write the equation of a tangent line again. So let's write that down again. So y minus y1 equals m times x minus x1. And we're working at an x value of 3. Okay, so the first thing I'm going to do is I'm going to find out what my point is at 3. So if we look at our graph right here, they've told me that this is the point 3, negative 1. And then I also want my slope. And that is a sharp turn right there, so I'm going to have a slope that is undefined. And so a slope that's undefined is going to be a vertical line that is running directly through that point 3, negative 1, or that's going to be an x equals line. So I'm going to say that the equation of that is where x is equal to 3. Okay, and finally, I want to find the x-coordinate of the points of inflection on this graph. Okay, a point of inflection is going to talk about where it is changing, or where G is changing in concavity. So with G, we are talking about concavity. Okay, so with G prime, we're going to be talking about where it's changing from increasing to decreasing, or vice versa. Okay, so with G prime, which is the graph that I'm looking at, we change from increasing to decreasing, where x is equal to 0, and then we continue to decrease all the way to where x is equal to 3, and then it changes into increasing. Okay, so I'm going to say that points of inflection exist when G prime changes from increasing to decreasing, or vice versa. And that would be a good justification for that. Okay, on 24, we are looking at a table here, and it is asking us some questions about some Riemann sums. So I'm going to be looking at some rectangles, and first it asks me to go from the left. So let's find first for part A the area from the left, and I'm going to be talking about approximately. So if you look at your table, my first base of my rectangle is going to be between 0 and 4, or 4. This one is going to have a base of 5, and so on and so forth down the line there. All right, so let's start with my base of 4, and I'm going to work with my height that's on the left. So on the left of that rectangle, I would have 25. Okay, then between 4 and 9, I'm going to have a base of 5, and I'm going to have a height of 28. Okay, then in my next rectangle, between 9 and 17, I'm going to have a base of 8 and a height of 33. And then finally, between 17 and 20, I've got a base of 3 and a height of 42. All right, so this is going to give me 100 right here. Let's go over on the side and do a little math with that. So that's going to give me 40, and 10 gives me 140. And 33 times 8 is going to give me 24, so 26 right there, 264. And then 42 times 3 is going to give me 126. All right, let's see here. I'm going to work with this together. This is going to give me 240, so 440, and then 504. 604, 624, so 630. Did they give me units of measure on this? Yes, in gallons. Okay, the only difference on part B is that now I'm coming from the right-hand side. Okay, so I'm going to use the same bases, but I'm going to come from the right. So from 20 to 17, I'm going to say I have a base of 3. And then on the right-hand side, I have a height of 46. All right, from 17 to 9, I have 8. And then on the right-hand side, I have a height of 42. And from 9 to 4, I have a base of 5, and I have a height of 33. And then from 4 to 0, I have a base of 4, and I have a height of 28. Okay, so same thing. Let's do a little bit of math with these. So 46 times 3, 18, 12, 13. So that's going to give me 138 plus 42 times 8 is going to give me 16, 33. That gives me 336. And 33 times 5 gives me 15, which gives me 165. And 28 and 4 gives me 112. Okay, and so now I'm going to add all of that together. And that's going to give me 751 gallons. Keep forgetting my units of measure. Okay, and finally on part C, change paper and talk about part C. So on part C, this time I'm working with a trapezoid. I can't use the formula for a trapezoid because I do not have the same intervals, the same bases or heights on these trapezoids. So I'm going to need to work with each one at the time. So my area of my trapezoid is going to start with 1/2 for my formula, and my first height is 4. And then I want to do base 1 plus base 2. And then 1/2 of 5, the distance between 4 and 9, and then base 1 plus base 2. And then 1/2 of 8, and base 1 plus base 2, and 1/2 of 3 with base 1 plus base 2. Okay, and so this is going to give me 1/2 of 4 gives me 2, and these together, that's going to give me 53. And then I can write this as 5/2 times 28 plus 33, which gives me 61. And then 1/2 of 8 gives me 4, and 33 and 42 gives me 75. And then 3/2, and that's going to give me 88. All right, that's going to give me 106 right there. This is going to give me 152.5 when I multiply those together. And 300 and 132, because 2 will go into 88 44 times 3. And so all of that added together gives me 690.5, again, gallons. Okay, you can check your answer because they all should be a little bit close to each other. You should have numbers that are all kind of in the same ballpark. Okay, on 25, we are working with these two graphs that are right above, the graph of F and the graph of G. And I want to find out if H is F times G. I want to find H prime at 4. So let's start by writing down my formula for H prime of X. And this is going to need a product rule. So I'm going to have G F prime plus F G prime. All right, so let's fill in the 4 to that. And then I'm going to go and take a look at my graph. And G at 4 is going to be a point. The derivatives are then going to be the slopes at those points. So then I can go to my graph, and look up what our values are for each one of these. All right, so I took my graph and kind of labeled here. I don't know if we can see that. They're kind of small. So this is going to be 1, 2, 3, 4, and 5. And then I have 1, 2, 3, 4, and 5. So what I'm going to do over here on my formula is, let's put some parentheses in so that I can then go through and fill in. Okay, so I'm going to do this one first. The graph of F at 4 has a point right here at 5. So F at 4 is going to be equal to 5. Okay, then I'm going to look at my graph of f at 4,